Hello folks, it's Devin Gill, and today we're going to once again dive into the wonderful world of statistics, the z-tests, the c-values. We're going to learn all the 9 yards today. And this video today is sponsored by Nesquik. Nesquik, the taste you love. So today we're all going to do a problem and we're all going to do it together. So you might want to get your pens and notepads out so you can just follow along with the video. It'll be much easier. You can always pause the video and go back if you wanna look at earlier parts. So I'm gonna get one of my friends to come and help us today. Thank you. Enough!
Hi class, Professor Kunta is here, and today we're going to go on a little trip. We're going to test whether the tastiness of chocolate milk has changed from 65% from a unanimous sample size. People from Fresno State to come out, and I surveyed them, and 310 of the 500 flavors that the chocolate milk has changed. You know, we're going to use a two-tailed test for this, not a one-tailed, a two-tailed test for this to test the hypothesis of the proportion of chocolate milks that say that chocolate milk has changed. Let alpha be a 0.05. We're to calculate the t-statistic, state the critical value, and state the conclusion about the null hypothesis. And we're going to state what we conclude during this trial.
Okay, so now we will proceed to do the problem. So first of all, there is 500 students total. And out of those 500 students that were surveyed, 310 out of the 500 favor that chocolate milk has changed. So we're gonna divide this and we get 0.62. And then for the next step, what we're gonna do is we're gonna get the standard error. So the standard error, the SE stands for standard error. So equals, so the square root, the 0.65. The 0.65 is from the 65%. They're the 65% of the students, and then times 0.35. And where we get this from is we subtract 1 from 0.65 and we get the 0.35. And now let's put that over 500, which was the total number of students. We go ahead, put that into our calculator, and we get 0.0213. And so that's what we get right now.
So we're going to go to our critical value test and find the critical value equals 1.96. I want to circle this because we're going to come back to this. This is going to be a very key number. So we're going to get the z-test. We're going to do the z-test. So z equals 0.62, which is we got from here, minus 0.65. We're going to divide that over 0.213. This is going to equal negative 0.03 divided by 0.0213. That equals a grand total of negative 1.408. So this is what I said. So we got our number of negative 1.408. This is when the critical value, as I told you, will be very key. Since this number is smaller than our critical value of 1.96, we fail to reject the null hypothesis. What that means is that we cannot conclude that chocolate milk has changed.
A critical value is a point on the scale of the test statistic beyond which we reject the null hypothesis. A two-tailed test is a statistical test in which the critical value of the distribution is two-sided and tests whether a sample is greater than or less than a certain range of values. So this is it for today, folks. For me and Professor Kunta, so long from Irvine, California, and also Nesquik, the taste you love.